exciting. One reason is that we can use blockchain to create a currency like Bitcoin. And so Bitcoin was our first blockchain application, and it was announced with the Bitcoin white paper back in October 31 of 2008. And the basic idea was to use the blockchain layer underneath Bitcoin to create a currency with irreversible transactions. So you write the transaction blockchain, and no one can ever remove the transaction or undo it. Now, you may ask, why do we care about a currency with irreversible transactions? Well, let's think about how we spend money today. Let's put aside cryptocurrency and things like that. Just think about how you buy some stuff. If you're at the grocery store, you might pull some dollar bills out of your wallet to buy something. If you're online, you might shop with an online merchant and use your credit card. Alternatively, at the grocery store, you could also use your credit card. Well, if you use your credit card to buy something, you're actually buying something with what we would call a reversible transaction. That is, there can be chargebacks where you can complain to the credit card company, hey, this merchant didn't give me the product I ordered online, and then the credit card company will refund you and basically charge back the merchant, and the merchant doesn't get paid. So the idea was to use to try and build the online equivalent of the dollar bills in your wallet. Because if you use the dollar bills in your wallet to buy something from the merchant, you can't then complain to the credit card company that the merchant didn't deliver what he was supposed to. So we consider cash an irreversible transaction, whereas a credit card is a reversible transaction. And so the idea was to create something like cash. That was the idea behind Bitcoin. And Bitcoin was not the first attempt at a digital currency, but it was the first one that was actually successful. We had tried, different companies had tried other digital currencies for about 20 years before Bitcoin, but all of those other digital currencies failed. But the launch of Bitcoin really started off this whole revolution. There's been over 6,000 different cryptocurrencies created in the last 12 years since Bitcoin was launched. But probably the most famous of the other ones is Ethereum, which I'll mention briefly as well. So there's been over 6,000 cryptocurrencies. Venture capitalists are investing billions of dollars every year, and they're hiring a lot of people to work in startups. There's been these things called initial coin offerings. Over $20 billion was raised in the past 4 years. Also on the IP side, there's been a tremendous interest in blockchain because people see this as a future of many different industries. So there's been over 30,000 blockchain patent applications filed in the last 10 years. Just to give you an idea of some of the interest. So again, we talked about the fact that what is a blockchain? It's basically the shared ledger that provides coordination between multiple parties when there's no single trusted party. And if you do have a trusted party, then you won't use blockchain. So for financial systems, oftentimes money's at stake. Nobody trusts anyone else. And so blockchain is a perfect fit for the financial world. But there's a lot of other places we might use blockchains. Digital asset management, online games. There are these, the Federal Reserve of the US and its competitors in other countries, central banks in other countries, are also looking at using blockchain to create digital dollars and digital euros. And so we may see, official legal tender as cryptocurrencies being released by all the different governments across the country in the next couple of years. So there's a number of different possible applications besides the digital currency that I talked about. Obviously, there's been a number of different digital currencies out there, Bitcoin, Ethereum, and about 6,000 others. But besides these digital currencies, there's also these things called decentralized applications, sometimes abbreviated dApps or DAPP. And so there's a wide range of things going on in this decentralized application world. Basically, you can think of a decentralized application as somewhat similar to like running a program on a particular platform. So let's take it for example. Let's suppose you're familiar with databases and how databases work. Well, you can write a program where you've got, like, say, a JavaScript program that is calling a SQL query against the database, and then you get back a response from the database, and then you do something with result set you got back from the database, and you may display that to the user. Well, in addition to that simple example of a JavaScript program calling, sending some SQL to the database and getting a result set, you could also, for example, have stored in the database some SQL code ahead of time, a stored procedure, for example. And then that stored procedure executes in the database, running some SQL, and then sends a result set back. Similarly, with web applications, we often try and run the web application up on the web server as opposed to just running on the client side. Well, with blockchain, you can try running an application actually inside the blockchain. And so that's what these dApps are. They're actually programs that are running in the blockchain and then doing something. They might be just doing some validation or on a transaction, double checking the transaction to make sure it's doing something in particular. But there's a lot of other things you can do. You can set up lending applications. You can do exchanges where people exchange one cryptocurrency for another. It's possible to generate new currencies through a decentralized application. Like, for example, I showed you earlier that picture of the crypto kitty. Well, that's actually being generated by one of these dApps. And it keeps track of all the different crypto kitties and makes sure that only one person can own that unique crypto kitty, which by making limited it to only one person owning that specific one, you are generating a value. It's like a collectible that is a rarity of one. There's a lot of other possibilities for these decentralized applications and asset management, domain names, games, and so on. But in addition to the fact that we can create these new capabilities for decentralized applications, we're also dealing with a new type of programming. Writing decentralized programs to run on the blockchain has some similarities to previous types of programs we run. I mentioned stored procedures or web applications that run on a web server, but in some ways it's very different from the types of programs we've run in the past. Because what happens is with the blockchain, we're creating a peer-to-peer network of all these nodes that are communicating back and forth. So our programming model has to take into account of the fact that our program is going to be massively parallelized and communicating back and forth. And so that has some interesting characteristics that make it a unique programming environment. And so we use different programming languages to actually write these programs that are on the blockchain. Here's a look at some of the many applications and projects that are currently on Ethereum in the decentralized finance area. They've got payment projects, investing projects, marketplaces, prediction markets, credit and lending, insurance, derivatives, KYC, and identity projects. They also have this thing called stable coins. So you probably saw that slide I showed earlier about Bitcoin, showing Bitcoin's up and downs over the last year. Well, stable coins are a little bit different from Bitcoin in that they're designed to have a constant value. So, for example, the USD coin is designed to always be worth $1. You might ask yourself, why would I want to have something that would always be worth a certain amount of money? Well, the reason is, let's suppose you believe the market is going to tank tomorrow. You might pull your money out of one currency that's volatile and put it in a safe currency that you know will not change. So that's, and there's a lot of stablecoin projects out there. I show like 20 here, but there's actually probably closer to 500 or 1,000 stablecoins out there. And yeah, on this particular slide, I'm probably showing no more than a couple of hundred different project names, but there's literally thousands of companies and organizations that are putting together blockchain projects out there. So this is a tiny subset of all the different blockchain projects that are going on right now. So let's talk a little more in detail from a technical perspective as to how this blockchain technology actually works. So blockchain is based on cryptography. In particular, it's based on a cryptography capability is referred to as hashing. It also leverages public key, private key encryption, and it also leverages digital signatures. But basically, how a hash function works is it takes any particular string as an input as a fixed sized output. So you can have something that's terabytes in size, you pass it in to the hash function, and your result is 256 bits in size. And the idea is that it's collision free, that nobody can find x and y, such that x is not equal to y, and the hash of x still equals the hash of y. And so here's a look at what a blockchain actually is. It's a linked list of hash pointers. So if you're familiar with linked lists from the computer science area, basically you've got several blocks of data, and each one has a hash pointer to the previous block. So block number 2 here has its data, and it's also got this hash pointer, which is basically a hash of this previous block. And then let's suppose a hacker comes along, and a hacker wants to modify block number 1. A hacker could do that, but then block number 1 will no longer match the hash pointer that's in block number 2. And so that's why we say that blockchain is tamper evident, or it's immutable, because we can always detect tampering by hackers or inadvertent tampering where there was a hardware failure and the data was corrupted. And so that's why we say that blockchain is more secure than previous technologies, because we have this ability to detect the fact that it's been tampered with. And in fact, in addition to doing it as a linked list with hash pointers, you can also do a tree, which is often referred to as a Merkle tree. And we use that typically when we want to store a lot of data, because a linked list is inefficient for a lot of data, but a tree is a lot more efficient for a lot of data. And so the Bitcoin block structure, if we were to actually dive in and look at it from a technical perspective, is this series of blocks where each one has a hash pointer to the previous block, and each block has a transaction tree of all the transactions. Individual block in the Bitcoin block structure might have 1,000 or more transactions in it in the tree form, and then it's just got a hash of that, and then the next block in the blockchain has a hash pointer to the previous block. And all of this is cryptographically protected by these hash links, so that a hacker cannot hack the Bitcoin blockchain. Now, there are a couple potential vulnerabilities in the Bitcoin blockchain, but they're extremely difficult for a hacker to attack. And so I've mentioned the fact that in addition to hashing, we're also using public key, private key technology and digital signatures. Basically, we use public key, private key to generate the digital signatures. And the digital signatures are how we determine who actually owns the cryptocurrency. And so you use what's called a private key to sign and spend your cryptocurrency, and your public key is used to allow people to pay you money. And you keep your private key private, and as long as you keep your private key, only you can actually spend that currency. But of course, if you lose your wallet device that is storing your private key, then you will lose your currency. And so, in fact, of the cryptocurrency that was created in the first year of Bitcoin, no one has ever spent any of that currency. It's possible they still have it all on their private keys. It's also possible they lost their private keys because it was 12 years ago, and therefore they've never actually gotten around to spending it. So there are a lot of ways in which you can become involved in the cryptocurrency and blockchain space. There are numerous hackathons and other events that are giving away cryptocurrency. Get some currency for free. One example is a Chainlink hackathon, which just ended a couple days ago. It had prizes worth over $125,000, and everyone that participated received a minimum cryptocurrency of one link, which is Chainlink's cryptocurrency. There are airdrops and other approaches that cryptocurrency projects are using to give crypto away for free. So definitely everyone should think about how they can become involved in the industry and the technology transformation that is taking place. And the main reason we call this cryptocurrency is, again, because the currencies are relying on cryptography. They're relying on public key, private key, and hashing and digital signatures to secure the currency. So my second half of this talk is really diving into some more details on how you can become involved in the cryptocurrency, and a few more details about how I got involved in it. So one thing to think about, and probably some of you have already seen this, is technologies go through waves of visibility And Gartner, the consulting group, has actually called this the Gartner hype cycle. And the idea is that when a new technology is released at this technology trigger point, the technology gains visibility rapidly to the point where it reaches the peak of inflated expectations. I mean, everybody thinks the technology is magical and it can accomplish everything. And then as people begin to discover the technology isn't really magical, it's just science and engineering, and it can't do everything, it drops in terms of visibility and goes through what Gartner calls a trial of disillusionment. And then over time, as the technology matures and people begin to realize, hey, this technology is good for A, B, and C, it begins to become more popular again and goes through the slope of enlightenment. And then finally, as it becomes a routine technology, then it's on the plateau of productivity, and it's basically staying the same. Now, where is blockchain and cryptocurrency? It's a really interesting question. And I would say that you you don't really want to analyze the entire industry at once. You probably want to analyze specific technologies. So I would say Bitcoin and Ethereum are at different points in this Gartner hype cycle. In fact, I would say Bitcoin is probably on the slope of enlightenment, where I would say Ethereum is probably at the peak of inflated expectations or going towards the peak. It might not be at the peak yet. Similarly, as I mentioned, there are thousands of other cryptocurrency technologies besides Bitcoin and Ethereum, and they also might be at very different points in this Gartner hype cycle. So over the last 25 years, I've been involved with a lot of different hot technologies. Back in the 1990s, I was involved with the World Wide Web and the web applications. Then when Java came out as the first active content that could be used on the web, I got involved with Java and virtual machines, the Java virtual machine. Then search engines came out in the late 90s, Yahoo, Google, and all the rest. Then service-oriented architecture and cloud services and mobile apps and social apps, big data. And now, all throughout this time period, computer security and AI were very popular and hot. And then lately, about 4 years ago, I got into blockchain and cryptocurrency. And then about a year and a half ago, I started getting involved in quantum computing. And I've seen all these technologies, and they've all gone through that Gartner hype cycle I showed in one way or another. So I think that there are really three types of organizations out there. There are organizations that are growing in the number of employees, they're hiring, they're acquiring other companies and so on. There's organizations that are shrinking, maybe they're doing layoffs or people are leaving and not being replaced. And there's organizations that are staying roughly the same size. Although the internal units may have a lot of turnover and change, the overall organization size stays the same. And I believe that fun is achieved from being in a growing organization or working with a hot technology, and that the maximum fun is obtained when doing both, i.e., a growing organization and a hot technology. And I put Dean in parentheses after fun because I've also found that funding tends to flow the same ways. That the organization that's growing and is covering a hot technology tends to have the maximum amount of funding compared to other types of organizations. So if you want to get more involved in any part of the blockchain technology or information technology in general, one thing you should always remember is that communication is really important. If I've heard many people say that IT equals people, process, and technology. Well, of those three, people, process, and technology, people are the most important component. So effective communication is your most important IT skill. Satoshi Nakamoto, the founder of Bitcoin, claimed that he was a better programmer than a speaker. I don't believe him on that because, yes, he created this fantastic new technology that is literally changing the world. But he also wrote the best computer science white paper of the last 50 years. And so I think that actually he was a better writer and communicator than he was a programmer. He was a lights out genius level programmer, but he was an even better writer. Now, you don't need to be on a social network to communicate effectively, but you do need to be able to contact people when necessary. Um, so, how do you find a position in the blockchain industry? So, the first thing is don't have preconceived notions of who's going to hire you or what they're going to want. You don't know who needs your skills, so talk to everyone. When applying for jobs, it's okay to submit applications online or to a recruiter. You should attempt to find who the hiring manager is and communicate directly with the hiring manager. And I'll give you a couple of examples. About 15 years ago, I wanted to get a position in Silicon Valley. And I applied for the position. I looked at the position. I thought I was perfect for the position. I never got a response. I had sent the email to the recruiter, and they just never responded. So about a year and a half later, I saw that the company that was originally had that one ad that was perfect for me, they still had it out there a year and a half later. So I decided, okay, I'm going to try this again. So I figured out and I analyzed who worked for that company. I found someone who worked for that company who we had something in common. We had gone to the same university. Now, we didn't do it at the same time from a year perspective. I didn't know this person at all, but I found out that they worked for the university, and I reached out through my social contacts and I contacted them and I said hi. And I said blankly, hey, this is my background. Does your organization have a position that would fit me? I got a phone call within about an hour. I had a job interview the next day, and I was in Silicon Valley the week after that for an in-person interview. So it's really important to talk to a real person and not just a recruiter if you want to actually find a position. And I'll give you another example. Um, Getting back to you don't know who needs your skills, so talk to everyone. About 10 years ago, I was applying, I got called by a recruiter out of the blue. And I was like, and she said, Company X, needs someone with your skill set. And I knew that Company X had recently done two acquisitions, uh, and they had acquired companies that had people with my skill set. And I knew that before they did that acquisition, they originally had some people with my skill set. So just based off the recent acquisition activity and their pre-existing employees, I was convinced they had three times the number of employees they needed. So what did they need me for? Well, it turns out that because of those recent acquisitions, everybody left. And so they desperately needed me because they had three times the amount of work they originally had, and all their employees had left. So you don't know who's going to need you or what they're going to want. So talk to everyone. And that's your best approach to finding positions, whether you're looking in the blockchain industry or somewhere else. Now, sometimes I hear, hey, I want to do this new technology area, but I don't have any experience. And all the jobs are asking for 5 years of experience or 2 years of experience. So, one of the things you can do is you can get a technical certification. Technical certifications are often recognized as an experienced substitute for job positions. So if you think about it, if you're interested in working with a technology and you want to make hundreds of thousands of dollars in pay for working for that technology, the price of a technical certification, at hundreds of dollars or even thousands of dollars is a lot cheaper than the amount of money you're hoping to make when you work with that technology. And there are many online websites these days that can help you prepare to pass the certification exam. It's never been easier to pass certification exams. 30 years ago, it was a lot harder to pass certification exams. Finally, let's suppose you need to find experience because you can't find a full-time position. Try and find a part-time or a volunteer position doing what you want. That part-time or volunteer position can then turn into a full-time position at a different or similar organization. Nonprofit organizations and open source projects need help all the time. Um, and even if you're not a hardcore programmer, you could do documentation work, or you could do, public relations work to help that open source organization. There's a lot of things you can do to show your commitment that can then lead to full-time positions. For example, if you volunteer to help with Linux, you might be hired by Red Hat or IBM or another company that supports Linux. One last comment is on resumes. I would stick to a one-page resume. I have a long career and I stick to a one-page resume. And I put the most important information at the top of the page, like how to contact me and what my name is and what type of job I want. And your resume should be written specifically for the job you're applying for. If you're applying for multiple jobs, then modify your resume every time you apply. And the other thing to keep in mind is put networking information in the resume. What schools you went to, what other companies you worked for, social or volunteer organizations you're involved with, all the ways that people might know you or things they might have in common with you. Tasks and job duties should be listed, but they're not as important as networking aspects. And the last comment on how to find a position in the blockchain industry is when you're actually doing an interview, be positive and optimistic. Ask questions about the interviewer's job and the company. And nowadays, with these online interviews, write down some questions ahead of time. You can have them on a piece of paper next to you while you're interviewing. And questions shouldn't have obvious answers or answers on their website. Instead of asking if a company has a cloud service, for example, which you can find out on their website, ask them how their cloud service is different from their competition, which you might not be able to find out on their website. And talk about things you have in common with the interview. Build a relationship. Make the interviewer believe that you're engaged and interested in what they're doing. And finally, one last thing to keep in mind is rejections happen to everyone, and they happen for reasons out of your control. Don't worry about rejections. Just keep on applying. And then one last thing is that people join companies, but they quit managers. Companies have cultures, but individual positions will vary dramatically in an organization. You might join a company, discover the position they gave you is awful, but that doesn't mean the entire company is awful. It just means you have to get out of that position and find a better position. So that's my brief comments on how to get a position in the blockchain industry. And I want to open it up to question and answer.
Thank you so much, Thomas. Fascinating what you're talking about. This is such a new industry and it's changing all the time. I would encourage people to ask questions. Feel free to ask questions, put them in the chat box. But it's not every day that we have access to somebody this deeply knowledgeable about blockchain and cryptocurrency. And this really is a foreseeable future. Of course, nobody knows what's going to happen in 5, 10 years, but certainly this is not going away in the next several months or probably in the next couple of years for sure. We're going to be doing some sort of digital or work.
I mean, there will be changes.
Exactly. We're going to have some sort of.
There will be a lot of volatility. There will be a lot of changes, but I think electronic cash is here. Whether it's Bitcoin or it's a Fed Reserve coin or something else, I think electronic cash is going to be here for the long term.
Yeah, I agree with you completely. But of course, I'm biased because I'm a digital arts person. so in terms of so I'm leaving this open to everybody here. Feel free to ask. Thomas, you're okay taking questions, right? You said you opened it up to questions and answers. So feel free to ask questions, everybody, and don't be afraid to ask something if you're unfamiliar with the topic. This is a topic that's really important for you to get familiar with. So this is a really unique opportunity. Ruchi, you have a question? Go ahead and ask it.
Yes. Can you repeat what is stablecoin? That was the term, I think. You said the price doesn't change. What was the term again?
Yeah, stablecoin. Yeah, let me.
Stablecoin. Yeah.
Right here. So I mentioned stablecoins here on this Ethereum decentralized finance slide. There's a lot of other stablecoins. Not all of them are based on Ethereum, but The idea is that a stable coin is has a value that is based on a commodity or a group of commodities, or it's based on an algorithm. And so the idea is they want to create a currency that's not going to be volatile. It's not going to vary over time. Bitcoin's price varies quite a bit over time. 10 years ago, it would have cost you 10,000 Bitcoins to buy a pizza. In fact, that was the very first Bitcoin transaction, was like 10,000 Bitcoins for two pizzas. Nowadays, if with Bitcoin costing about $60,000, you could get 6,000 pizzas for one Bitcoin. So that's a big volatile difference in just 10 years. And so the idea behind stable coins is we want to be able to keep the money the same price, so that you put $100 into your stable coin today, that tomorrow and a year from now it's still worth $100. And so there's a number of different stablecoin projects out there. This little diagram here shows a number of the Ethereum stablecoin projects, but there's many other stablecoins that are not based on Ethereum. And I think there's probably over 1,000 different stablecoin projects out there in the industry.
Right. So my question is, as you said, there would be no profit earned, or the prices don't go up, so you don't earn any profit. So the only benefit you have is when the prices, as in the prices don't change, it's stable. So how do you benefit from that?
Well, you benefit from it that you don't lose any money when the prices go down.
Oh, okay.
Bitcoin also goes down. It goes up and then it goes down, up and down, and so you don't lose any money.
Okay. And the prices for stablecoin are not the same as Bitcoin, right?
Yeah, typically they're going to be based on a commodity, and usually a lot of them are based on the idea that it's going to be a dollar or a euro or whatever it's based on.
Right. Okay, makes sense. Thank you for that.
Hi, Thomas. This is Radeja here. I had a couple of questions as well. I'm a lawyer by profession, and I am a venture capital lawyer, so I work with startups quite a lot. And I have worked with cryptocurrency startups in the past.
Great.
So my question is more towards legal regulation, since you're a patent attorney. I thought it would be a nice discussion, or a nice way to get to know your opinion about it. So as of now, several countries don't know how to actually regulate cryptocurrencies. I'm from India, and India actually introduced a bill recently that banned private cryptocurrencies and only allowed government cryptocurrencies. So it's not been put into effect, but they are voting on putting that as a law. So what is your thought on legal regulations? Should there be like a uniform regulation that would govern all cryptocurrencies around the world?
So that's a really interesting question. So what I would say is that there's going to be a lot of change over the next 10 years, and a lot of change this year. In fact, this is probably going to be the biggest year for legal regulation of cryptocurrencies since 2018. And so there's going to be a lot of change. I mean, I'll give you the example, the US. So in the US, Bitcoin and Ethereum and these other cryptocurrencies, they're not considered legal tender. They're not the equivalent of the US dollar or even the euro. They're considered property. But, if you buy and sell Bitcoin, you actually have to pay capital gains on the amount of money you made on your cryptocurrency, as opposed to it being treated like normal income. So that's something to think about. I do think that as these Federal Reserve and the other central banks begin to release their currencies, that's going to have a big impact on the regulation of cryptocurrencies in general. The Federal Reserve is currently doing a pilot with MIT. They're supposed to release the results of their pilot this summer. One of the people who's running that pilot recently spoke at MIT a week or two ago at the MIT Bitcoin Expo. And so you can read what he had to say. Also at that MIT Bitcoin Expo, they had someone who had worked on the UK's central bank's its pilot, and they also had someone who was deeply involved in what's going on over in China. So there's a lot of interest across all of the different central banks on how to implement these digital currencies. They're all currently looking at doing pilots of various types. Now they have to deal with a lot of different issues. Some issues of scalability, issues of who's going to be charged, transaction fees. They've got a lot of different issues to work through. I mean, to give you an example, currently, if you're doing a cryptocurrency transaction, the party that is pushing the transaction out to the blockchain pays a transaction fee. That's a little bit different from how we handle cash transactions. You know, if I'm buying some groceries from a merchant using cash out of my wallet, there's no transaction fee. There's sales tax, but there's no transaction fee. So, I mean, there's some certain things that the different central banks need to work through on exactly how they're going to handle these currencies. I think there's going to be dramatic change in the regulations of these currencies this year and over the next couple of years.
All right, thank you so much. And just to follow up on that question, what do you think is the best approach that lawyers should take when they're testing out and using this technology? Especially because a lot of talks have come about that blockchain might be used to store confidential information, and the fact that blockchains can be private and public, as you explained. Do you think there's a possibility that hackers could actually get a hold of the public key as well and get into the confidential information?
Okay, so that's a complicated question, and so I'm going to answer it in multiple parts. All right. So the first thing you mentioned was private blockchains. I haven't actually talked about private blockchains in this lecture, other than to mention briefly, I mentioned Hyperledger Fabric, which is a type of private blockchain. You can also do Ethereum as a private blockchain. And theoretically, you could do Bitcoin as a private blockchain, but nobody does. So a private blockchain is a blockchain that's running in your data center or multiple organizations' data centers. And basically, you've created a private public blockchain anybody could use. So if you want to deal with confidential information in a blockchain, it gets kind of tricky because typically, you know, if you think about it, the way we are handling, let's go back to Bitcoin, for example, and then I'll dive into the privacy issues with it. The basic idea of Bitcoin is that the information is not confidential, but the identities are going to be pseudonyms. It's just like if you're using an anonymous email address that you created, like you created mysecretemail@gmail.com. Well, instead, in the Bitcoin world, you create this Bitcoin address, which is basically your public key, and it's a randomized sequence of characters. And so when someone looks at that randomized sequence of characters, they don't really know who you are, unless they do some really fancy TCP/IP networking to track you and figure out who you are. So we would say that a Bitcoin address is a pseudonymous address. It's not true anonymity, but you know, it's kind of like having an email address that no one recognizes, so they don't know who you are. So the idea is you make the transactions public on the Bitcoin network, and so all the details of transactions are out there. But since no one really knows who you are, because it's a pseudonym, it's okay more or less from a confidentiality perspective. Now, I mentioned earlier there's like 6,000 different blockchains. There are some blockchains that provide a great deal more privacy than Bitcoin does. Both the private blockchains I mentioned, so they're running on your own network, they're not out there in the public networks. There's also you know, some confidential blockchains like Zcash and Mimblewimble, which even make the transactions hard to follow. So they make it much more difficult to, even if you could figure out the pseudonym as to who it is, you won't actually be able to figure out what transactions they did. And so there's a number of different experiments going on with exactly how to add confidentiality, because sometimes people want confidentiality. Maybe, for example, a corporation wants to pay someone in Bitcoin, but they don't want the whole world to see that that person's salary is X numbers of Bitcoin every 2 weeks. So that's one example why people are looking at these confidentiality solutions. But a lot of that is a work in progress. And because this is new technology, there is potential vulnerabilities for hackers to get access to the information until we truly understand the technology and it's enterprise grade, which in many cases, again, this is early days of the technology, so it still needs some improvement on the confidentiality side.
All right. Thank you so much. And I'd love to connect with you offline.
Sure,
on LinkedIn.
absolutely. Happy to help.
Well, yeah, that's wonderful. We have a question in the chat box that says, could you explain more about NFT, how it affects digital arts market? Is it digital arts work copyrighted, protected when there's small changes that are made to it?
Okay, so that's another complicated question, but here's a nice little NFT that sold for 150K. So let's talk about NFTs. An NFT is short for non-fungible token. For example, this little information came from the nonfungible.com website. What is a non-fungible token? So Bitcoin is a fungible token. It's basically like the dollar bills in your wallet. You don't really, yes, your dollar bills have a serial number, but nobody really pays attention to that serial number. We just spend the dollar bills, and just like you would spend the Bitcoins, and you don't really pay attention to where they came from, other than that they're in your wallet. You want to buy something, so you spend them. So a non-fungible token, however, has a unique identity. In this particular case, for this crypto kitty, all this artwork and how this crypto kitty was set up and all the characteristics of it are all unique. It's a unique combination. So other people can create crypto kitties, but their kitty's going to be different from this one in one way or another, or many ways. So that's the basic concept of the NFTs. It's supposed to give you a unique item. And a lot of artists are diving into the NFT. One of my favorite crypto artists is Josie.io. She's doing a lot of NFTs. There are many other artists who are doing NFTs. In many cases, it's actually increasing the value of their artwork as well, because a lot of these crypto items are going through rapid appreciation, and so things that have been bought with those are also going through rapid appreciation. Now, the second question, the third question is a digital arts work copyright protected when some small changes have been made to it? So that's a copyright protection question. And it gets into issues of derivative works and modifications. And so it really is going to be dependent on exactly what changed, how it changed, and so forth. So I can't really answer that question without a lot more details. Okay.
That's a good question. I know a lot of musicians and celebrities are getting into this market. Can you talk a little bit about that?
Sure. So in fact, you can do so celebrities and musicians have gotten into the market for a couple different reasons. You could actually do NFTs with music songs and YouTube videos. And in fact, there was a YouTube video that sold for like $6 million. It was like a 10-second YouTube video. But in addition to the NFTs, you can get in, some musicians and celebrities are just doing cryptocurrency in general. So they're selling their songs for cryptocurrency and doing a variety of other things. So so NFTs is only one possible application that is applicable to the arts. There's many other potential blockchain applications that are also applicable to the arts.
So many people talk about blockchain as an equalizer. Can you talk a little bit about that, like a level playing field, an equalizer there?
Sure. Okay. So in that regard, typically it kind of has it's kind of similar to the recent Robin Hood versus the big traders controversy. This idea that the big institutions, financial institutions, have advantages that your everyday folks do not have. And so the idea is that blockchain puts everybody on an equal level. You have these pseudonyms. You don't know who's on the other side of that pseudonym. It could be, a 14-year-old in a basement somewhere, or it could be a major bank behind the pseudonym. Everyone is equal in the blockchain space. I also saw another comic strip that said, nobody knows your refrigerator in the blockchain space. You know.
Hi, I have a question.
Yes.
Hi, my name is Javier Cisneros, and
Nice to meet you.
I'm doing the degree in engineering management and IT.
Uh-huh.
What are the risks of a institution or a person accumulating 51% of the nodes of a like a cryptocurrency? Is that gives them the power to control the complete chain?
Okay, so let me answer that question. I didn't really dive into this, but if you go read the Bitcoin white paper, which was published back in 2008 in Halloween, and I actually released a YouTube video on it today, so I'll send a link later about that YouTube video. But basically, in that white paper, Satoshi Nakamoto, the founder, the pseudonymous founder of Bitcoin, it might have been multiple people, it might have been one person, points out that there is a potential vulnerability to Bitcoin if an attacker has more computational capability than the honest players have. Now, keep in mind, today in modern Bitcoin, there are literally millions of nodes running the Bitcoin blockchain. So an attacker would basically have to be one of the most powerful government organizations in the world to attack Bitcoin currently. But that still is potentially possible that a government could decide to go after Bitcoin. So let's talk about it. What would happen if an organization did what's referred to as the 51% attack? It's called the 51% attack because the attacker has over half of the computing resources in the network, so more than all the honest actors have. So if a dishonest actor has that much control of the network, essentially what they can do is they can do a couple things. The first thing they can do is they can control what transactions are processed on the network. So if I don't like you, I can prevent you from selling your Nana Mean Butt. So that's one thing they can do. They can basically lock out people from the network because they control the network. The second thing they can do is if they recently spent some money somewhere, they could then try and do what's referred to as a double spend, and they could potentially spend that same money somewhere else, basically counterfeiting their money. So those are the two potential things they can do if they control 51% of the network. Now, what they can't do is they can't spend your money because they don't have your digital signature, which is controlled by your private keys, and they have no access to your private keys, assuming you keep your private key secure. So all they can do is try and counterfeit their own money, which may or may not be successful, and they can try and prevent other people from being able to locking other people out of the network. Now, having said that, there's one major drawback to doing either one of those attacks. So let's suppose you spent billions of dollars to acquire enough Bitcoin machines to be able to do this. And you would need multiple data centers, massive data centers, the type of data centers that have million computer nodes in each data center to attempt this sort of attack. Can anyone tell me why you wouldn't want to do this, assuming you spent billions of dollars to build these data centers?
If I had to throw out a guess, it's because if people knew it was being rewritten, they would just abandon it, so then it would be worthless. So you have just wasted all your time.
Yes. If people knew that you were going to spend billions of dollars to harm the network, it would cause the price of Bitcoin to drop. And so you would have wasted billions of dollars, and then you wouldn't get any value out of it. So essentially, the defense against a 51% attack is not a computer science security defense. It's an economic supply and demand defense. Economic incentives protect Bitcoin just as much as computer security. And this was, I think, Satoshi Nakamoto's true genius. Is not that he was a great computer science programmer, but he also brought in economics at a genius level. And so he combined genius economics with genius computer science and completely changed the game in the financial industry.
Thank you. Makes sense.
I had a question regarding the digital signatures that you had mentioned during the
Yes.
lecture.
Mm-hmm.
So I'd read about a digital signature, which is also called blind signature. Could you explain how is that different from what you'd explained during the lecture?
Yeah, the blind signature is a special category of digital signatures. And I'd rather take that answer offline. But basically, the way a digital signature works is I mentioned these public key, private keys earlier. And so the idea is that if you think about a check for a minute, okay, think about a paper check. Normally, if you're going to write a paper check to someone, you've got your piece of paper, you've got on it who you're paying it to, the amount of money you're paying, you've got your bank routing numbers, and you sign the check with your using your pen. All right. But now what we want to do is we want to do this online. And so I want to, pay money to a person, and I want to sign it, but I don't want to just copy and paste my signature onto that because I don't want someone to be able to recreate it and pay themselves twice. So the idea of the digital signature is you're going to sign this check and you're going to have a unique signature based on your private key. Other people are going to be able to verify it by using your public key to verify it, but no one will be able to copy your signature onto another check so that they get paid twice. And so we use cryptography and this public key, private key to generate these unique digital signatures. And so all the transactions that are done in cryptocurrencies like Bitcoin, Ethereum, and so on are all relying on this cryptography layer of public key, private key, and using that public key, private key to generate digital signatures for spending, for transferring ownership of the CryptoKitty, Nanamemba, and so on. The blind signatures are a special subset of digital signatures where they're trying to hide certain aspects of things. And I don't really want to dive into it more detail than that, other than to say that kind of gets to some of the privacy elements we were talking about earlier, how people are trying to do things like Zcash, where they're hiding more information. And there's a lot of different attempts at that, and the blind signatures are one of those attempts.
All right, thank you.
Could I ask a question?
Sure.
Yeah, so it sounds like, correct me if I'm wrong, right? But it sounds like a lot of the barrier to adoption is in terms of government regulations. That I guess governments kind of want to regulate it so that I guess people can't lie about it or something. So where do you think currencies like Zcash or Monero fit in? Like,
so there are a number of different barriers to entry. First off, user experience is a barrier to entry for most technologies. And so the user experience needs to be easy. But private key and public key are not the easiest technologies for consumability purposes. I mean, and we are today using private key, public key underneath the covers in the web in many cases. You're using public key, private key, and you don't even realize it. But it needs to be sort of ubiquitous and easy to use. And the wallets aren't quite there yet in terms of being super easy to use. With regards to Monero and Zcash, those are growing rapidly. But again, they were developed several years after Bitcoin, and so they're even less mature than Bitcoin is. And so they're going to be going through some growing pains for some time to come. In terms of exactly when all these things are going to hit a critical mass, it's hard to say. It could be this year. It could be multiple years from now. We also have quantum computing on the future. Our first quantum computers are growing rapidly. It's still probably 10 years away before quantum computers are dramatically changing things. There will come a day when they do dramatically change things. And in fact, NIST is currently working on replacing all of our cryptography standards to deal with the quantum world that is coming. Now, of course, when those cryptography standards change, all the cryptocurrencies and blockchain technology we're talking about will also have to change to the extent that it's leveraging the cryptography standards of today, and they'll have to adopt the cryptography standards of tomorrow.
So does anybody else have any more questions? Thomas, thank you so much for answering these questions, by the way. These are, you have knowledge, not only do you have knowledge of the space, but I think your legal background is helpful for a lot of these questions as well. Does anybody else have any other questions? No? Okay. Thomas, I had one question, and that is, you've been in it for 4 years and you have all this background in it. I'm not going to ask you for any stock tips or any tips on purchasing cryptocurrency or Bitcoin or whatever, right? So what I'm interested in is, are you playing in the market? Is that something that you do? What is your favorite thing to do within the blockchain and cryptocurrency world?
Yeah, so my focus has really been on the technology side. I do own a little bit of cryptocurrency, but I am not looking at it as an investment perspective. I'm looking at it more as a technology perspective. Certainly, I have lots of friends who are investing in it, and I know, but my main focus is on the technology.
Fascinating. Does anybody else? I know that, Thomas, you're giving up your Saturday night to be with us, and we appreciate that. So I just want to ask, if we're going to give it maybe a 5-second count to see if anybody has another question. 5, 4, 3, 2,
One question. Sorry.
1.
It's Javier again.
Yep.
So I know that we discussed a little bit about NFTs, but the NFT is unique on its store or on its chain. What happens if you open a different store or a different blockchain? Can you have the same NFT in a different blockchain sold at a different price?
So that's an interesting idea. And in theory, you could. Now the reality is the people who create the NFT, they're going to create an NFT application, right? I mentioned earlier, there's these things called dApps. Let's see if I have it here. So you're creating this decentralized application, all right? And so, for example, you might put a decentralized application on a blockchain, and this decentralized application is generating the NFTs. And you've set it up so it's generating unique NFTs. And then you're going to go, you could theoretically take your decentralized app that you deployed here and then move it over to another blockchain, and then try and generate a unique NFT over there. Now, depending upon how you set up your dApp, that could influence whether or not it would be possible to create the exact same NFT over on that other blockchain. Now, even if you did that, it wouldn't be exactly the same thing. but it would be very similar. And so that gets into some issues of exactly how you build your NFT application. It's possible to create it in such a way that it would be extremely difficult to copy it. It's also possible that you could create it in such a way that it would be easier.
I see. So when you buy the NFT, you buy it in that specific blockchain.
Yes.
And okay, I see. And
presumably the people who are selling it, so like for example with CryptoKitties, someone actually built the CryptoKitty application. Presumably they would not want to create the CryptoKitty application on a different blockchain because they wouldn't want to mess with their current market, which is running well. So again, it's an economic incentive. They would not want to harm their market by diluting the market by trying to make available discount CryptoKitties on a different blockchain.
And yeah, in terms of security, then is there any way you can compare items that are in two different blockchains and making sure that there is no?
There are some ways to do that, but that gets complicated.
Okay, thanks.
I almost feel like if we look at somebody had a painting, a very famous Picasso, there wouldn't be two Picassos out there, right? So it's almost like the future of art, digital art, right?
Yeah, absolutely.
So Thomas, yeah. So Thomas, I want to say thank you very much. Can you stop sharing your screen for a moment? I want to take a picture with everybody here with you together.
Sure.
And let's go ahead and do that. All right, everyone, please turn on your cameras. Here we go. Hold on a second here. Okay, I need everyone to turn on your cameras, please. Okay. All right, I'm going to do a countdown here and then we'll take a photo all together, okay? All right. There we go. In 3, 2, 1. There we go. So Thomas, I just want to say thank you very much for spending time with us tonight. I know you have a lot of other things on Saturday that you could be doing. This was really kind of you to spend your time with us to give us some insight into a world that is definitely here and important for the future. Thank you very much for doing that.
Well, glad I could. Enjoy your night.
All right. Thank you. Everyone say bye to Thomas.
Thank you. Bye.
Thank you.
Bye.
Thank you.
Thank you, Thomas.